What is event sourcing? Event sourcing, I tried to find funny pictures. That's the funniest I could find. I guess I need Greg with the fish. Some of you probably saw these presentations by Greg made long time ago when the example of shopping cart, it's roughly, I don't know, Adam, please advise me, maybe 12 years old, maybe older. And when Greg did a talk on DD Europe, a decade of event sourcing, so I think it was 2 years ago, so it's 12 years now, 13. He said that's the last time he's going to show this. So I'm taking the estafette and showing this to you. It's the classic example of e-commerce. So sequence of events, cart created, 3 items added, 1 item removed, and shipping information added, and so on. So what does it all mean, this picture? So we are talking about moving away from storing the current state of entities or anything inside a system that is event sourced, and instead of doing that, we will store domain events. So domain events, as Eric Evans puts it, it's a pattern of domain-driven design, but it's not limited to domain-driven design. It's basically saying that it's something that happens and domain expert cares about it. So this is quite a bit different from what people think about events in general. So like there are events that could be representing something like transaction log in a database is basically a big event log, but it doesn't represent anything inside the domain. It doesn't have any business meaning. So domain events in contrary represent something that has a business value and a business meaning. So state mutations represented as something meaningful. It also basically represents on the timeline the history of changes and state mutations in a system. Events are stored in append-only fashion, so you cannot delete them as such. Well, you can discuss that. And normally you append it only, and you cannot modify them. That's a strict rule. So what happened is happened. You cannot change the past. It's like normal real life. So as soon as you store it, it's there, and you cannot modify it. And therefore, events are immutable. So they cannot be changed. Moving away from the shopping cart example, because it's pretty basic and a bit boring, although I will need to get back to it later. This is something that some of you would recognize. This is the tracking of the DHL waybill. So you can see that basically, yes, you are interested in the current state where your package is, but you also want to see how it got there. Sometimes, especially when it gets misrouted. So I got several situations when my package was flying back and forth between Amsterdam and Düsseldorf, and never got to me. So, and because I knew the history of things that happened with my package, I was able to call DHL and say, what's going on? So are you going to deliver it, or you just want to play ping pong between Amsterdam and Düsseldorf forever? And eventually they broke this cycle and somehow manipulate the system so the package was routed properly at the end. Sometimes it gets to customs and gets stuck there, and they don't even let you know, so you need to watch it yourself and call the customs office to get it cleared. Mic level. I can try. So is it better now with the mic level? I hope so. So this is a classic. I don't know if DHL is event sourced, but I know that they store history of all the movements for the package in some sort of log. And this gives the very interesting view on the history of the delivery. So one way of doing this kind of system is basically event sourcing it, because everything here represents a clear domain event. So as you can see, the arrival sort facility and processes for clearance and clearance event, they even call it an event, custom status updated. All of this, something happened in the past tense, is clearly representing the main event. So I look at several delivery companies, and they all have a log like this. And clearly, this state transitions for the package are represented as an event usually. This is another example. I'm sorry for the image quality. It is the best I can find. It's first Banco Wiki, so apparently it's a sample image. Transactions on your bank account are represented as individual records. So Greg loves this example. He used it several times. So when you call your bank and apparently you find out that your account is empty or even in negative balance, and you know that it was a few $1,000s before or euros, and you call them and say, what's going on? And they say, we don't know. It's a mighty table of the account balance that tells me that you have a negative balance. It's never going to work, right? So you need to know how you got there. And by looking at the transaction log, you find out what was going on your account. Someone stole your money, or you eventually just went overboard and bought an expensive TV or even a car. The same applies for counting and many other domains. I keep hearing that event sourcing is a niche technology or niche pattern. Actually, it's not, because a lot of businesses keep track on the history of things that happened in their business, especially when it's actually their core domain, like we call it in domain-driven design, something that matters. So if you look at state-based persistence, we only know one thing, it's a current state. So if you look at a relational database in a table or a document database like Mongo or even key value store database, you have an ID of your entity, you load this ID, query it, you get it by the key, and the current state of the entity is the only thing you know. The current state is the only thing you see. But you don't know many other things, like what it was before the last state mutation, why the state has mutated, and what happened throughout the history of the life cycle of this entity. And interesting thing that we often forget, what didn't happen. Like if you look at the state, what you can't see there, and maybe it's a bit confusing, so I'm showing you some examples. So what didn't happen, like shopping cart, I'm getting back to shopping cart example. Shopping cart has been created. Maybe the user just started to add things. It is implicit action. And $1,000 item was added. And then eventually the cart expired because the customer never checked out. So imagine the e-commerce system that would delete expired shopping carts, then you would have a complete data loss. In case that the shopping cart stays just marked as expired, you can find out that the item was there. So it's a better situation. Fine, so you can probably solve it like this. So it's expired, but the item is still there, and you can start nagging the customer, are you going to buy this or not? But what about this? The shopping cart was created, then $1,000 item was added, and then it was removed, and the $20 item was added, and then the customer checked out. In a state-based system, you basically see that there is a shopping cart, the $20 item, and they checked out, and you're happy you got $20. What you didn't know, and you don't know, you're never going to find out until you start keeping some sort of log or audit log that the customer actually looked at much more expensive item, and he probably or she wants to buy it, but apparently that's not a good time. Or I don't know, you need to wait until the paycheck arrives. So maybe the wife stands behind them. It's like, what are you doing? It's like, let me quickly remove it and then add less expensive item, but I really want that one. So there is a lot of information in history that disappears if you don't keep it. So there are a number of benefits of event sourcing, and I'm actually not going to go through them. It's probably another discussion that I'd like to have with many of you. So we'd like to collect some feedback after this webinar, what you would like to discuss. Dave, our CEO, discovered or formulated 12 benefits of event sourcing, and the log of state mutation is one of them. I know it's controversial because there are voices in the community saying that's not exactly the log. And I'm not trying to sell you event sourcing as the log system. That's what Kafka does, and we are not Kafka, so I'm not going to lie to you. And the reason why we do event sourcing is not only to keep the logs. So imagine things that you just need to look at the past and do some data analysis. Imagine that you want to do real-time event processing, but also keep events in place just for the case that you don't even know about at the moment. So there are many things that you could figure out when you actually have a history of changes. Sometimes it's very useful to understand what was going on in order to figure out why are you having this particular state of this entity right now. So I worked at the e-commerce company, or like say ERP, more or less a small scale ERP system, when I had a few SQL scripts that we executed when some sort of misalignment between warehouse current balance on one side and something else on the other side was happening. I worked there for 3 years and we never figured out the cause of this. So we were never able to fix the bug, but we knew where to look to find a problem and fix it. But we were never able to identify the root cause of the problem. So with the event source system, it would be very easy to do. And things like predictive analysis and behavior analysis would be pretty easy to do with event source systems. So don't get me wrong. So you can, of course, store events like that was updated, or you can have a status history. So if you look at the right side, I just took random screenshots from the internet. So you can see the status of something has changed from open to canceled. So, but what has happened? You don't know. I mean, it was canceled by support, so you probably can understand that someone from support eventually decided to cancel something that was open before. You don't actually understand. And somehow from protest, it was open. You don't know the business reason for that event to happen. So keeping just status updates or like saying this property changed the value from this to that, it doesn't give you enough information because it misses the essence of it. So basically the business reasoning behind a particular decision that was taken by support@esms.com. However, on the left side, you see that the status is still getting updated, like for example, shipped and downloaded and stuff like that. But it was updated because the item was shipped and it was downloaded and stuff like that. So you don't even know. I mean, this third line is order has been downloaded. It tells you information that has a business meaning and you know what's going on. So you know why it happened. Maybe you look at more properties in that event and you can find out a little bit more than just a simple status update. So people tend to have this idea in mind that you can implement event sourcing with so-called property sourcing. That property, or even making an event, it's called property updated. It's actually not going to solve any of your issues. If you have a dream building event source system, stick to the main events that have business meaning. So entity as event stream, as I see it, is I repeated several times during a couple of talks and hands-on sessions. Basically, for the first time, we have this ability to, instead of keeping the current state of the entity and basically orient the whole system or the subsystem to keep the state, we also can keep the behavior because events represent behavior. They do not represent, not always represent intent because we have actions and we have consequences. So we call consequences events. So they represent state mutations, but it's not necessarily the case that everything that user or someone else does with their system produces an event. For example, if you can't do certain things, you might decide not to proceed with the action. So you have a command coming from the from the user, and you say, no, you can't do that because your date of birth is not correct, or you haven't filled out a password, or something else is missing. So you might decide to store event about that as well. It's a pretty useful pattern. But to have a full audit log, you basically need to store all the commands and all the events, and then you have full observability of the history of things. But you can persist the behavior of persisting events. So you have things that happened and the user has, or other systems entered your system and basically produce some behavior. And this behavior result in the state mutation in the system. So in event source, state mutation is a consequence, is something that's recorded as an event and then the states get mutated. So we store entities in event store systems as event streams. And we tend to use a single stream of events. Basically, stream is a collection. We call it stream because it's like, adding at the end. That's just a popular name as well, right? The stream name, if you want to store entities in an event stream, you just need to give it some sort of ID, right? So the stream name is basically the ID of the entity. If you look at Mongo database, you have the document ID in a collection. So collection might represent your entity type, and the ID of a document is the random GUID. In the relational database, it's similar. So you have a table and you have an incremental int or GUID as an ID. So here we also do that. We don't have collections. We don't have partitions in event store in particular, but we can combine the things to formulate the ID. It's very similar to key value stores. So you can use entity type, hotel booking in this case, and its ID. I just chose the int as an ID to fit the screen, unlike the GUID. And this is your stream name. And then every state mutation is represented as an event. So it's reserved, it's bugged, paid, canceled, whatever. And then you can look at the history and decide what to do further on and what to do with the customer. And how you get to the current entity state. So imagine that you need to execute a new command and you need to know what state of entity is right now. So you basically load all the events. There are things there, I know, not getting there yet. But basically load all the events and apply them one by one. It sounds a bit of overkill, but it's not that hardcore. It's all these small state mutations of 1, 2 properties are very fast, and you load all the events at once. So in event store, we have max page size of events of 4,096. Usually in the normal business life cycle of an entity is limited to 1,000 events. So that's just an experience. And reading 1,000 events is not a problem. And each event has a version, so it starts with 0. When the entity just gets initialized, it's number 0, and then 1, 2, 3, and so on. It's often used to handle optimistic concurrency. If you work with entity framework or Hibernate, and Hibernate, you know that you might add a column that's called version, and you keep the version there. So if there will be conflicting changes, you can't do that because it will just say version doesn't match. You need to do it again. And by using versioning, if you try to apply the same event twice, it will say no because it's already there. So it makes the rights immutable and consistent. So appending events to the stream is a transaction. So you can add one or more events to the stream and it will be written in one transaction. So you keep your entity consistent. This is how you form your consistency boundaries technically. So this is all of event sourcing. I'm not going to go to CQRS and query models, so-called read models here, because we won't have enough time, because I still want to get to some discussion. And we will touch the query side of event sourcing later, in the next webinar.